Okay, we're going to be doing velocity and distance using integrals. Basically looking at the graph of velocity and seeing how an object would be moving. So some key things. If velocity is positive and the object's going to be moving right or forward just depending on the orientation. So again, if our velocity graph is positive, it's going forward or right on our graph. If the velocity is negative, the object is going left or backward. The integral, so that's the antiderivative when you fill in underneath the graph on a given interval, is the displacement. So if you take the integral, you'll be able to figure out how that object is moving. Now the total area between the curve and the x-axis, that's total distance traveled. Now displacement is where you end up. Distance traveled, you add forward and backward all as like amount of miles on your car is kind of what we're thinking there. We can find the total area again by doing absolute value of our integral. I think we've done that before in the past. If you don't have a graphing calculator, you can use Desmos.com. Might be a good backup for you as we go through this. So here's our function. It's a velocity function because you see the v of t is 4t squared minus 4t minus 7, and it's going from 0 to 3. So I want to put that into my calculator. 4t squared minus 4t minus 7. And I'm only concerned with this graph between 0 and 3, which is a pretty small interval. So here's my graph between 0 and 3. I can check my table here, get some values. At 0, we got a value of -7. So I'm way down here around -7. At 1, I got a value of -7. So I think the graph kind of went like that a little bit. At 2, I have a value of 1. So it looks like we're crossing over right before 2. And at 3, my value is 17, so we're way up here somewhere like that, right? So this is kind of the graph I'm looking at. You got some negative values, you got some positive values. And again, there's my graph on my calculator. So the first question is, when is this moving to the right? Velocity is positive, the object is moving to the right. So we want to see, where's the graph positive or above the x-axis? Well, from this crossover point to 3, I just got to find out where is this point crossing over. So an easy way to do that for us is to hit second calc, find our 0, left boundary, I'll hit enter there. Right boundary there, and it says, what, let me guess, sure. It says 1.91, you can kind of see right there. That's gonna be the point where it's at 0. But that's also where it stopped, right? Because it's not moving forward, it's not moving backwards, not moving right, not moving left, it's stopped. So 1.91 seconds is when this thing is stopped. That'd be that value right there. So when is it moving forward? Everything to that point to the right. So when is it moving to the right or forward? We're going to say from 1.91 to 3. And those are in seconds. Okay, so that's the time when that object's moving to the right. When is it moving to the left? Well, that's the rest of our interval that we're talking about. Again, we're going from 0 to 3. So from 0 till that crossover, which we said was 1.91, is going to be moving negative, which is backwards. So I'm going to say this is from 0 up to 1.91. Again, we're talking about in seconds. So that's what your first problems are going to be asking you about. Okay, now what is the displacement? Again, we got our graph here. I have a spot to sketch it. 0 is at like -7, 1, 2, 3. 3 is all the way up here at 17, 2 is at 1, and these are both like -7. So just a rough sketch here of our graph. The displacement is going to be, if we go back to our notes sheet, the integral on the given interval is the displacement. So that means really what we're doing is we're evaluating from 0 to 3 our function, which is 4t squared minus 4t minus 7 with respect to t. So this is what we're basically figuring out. We learned a couple different ways to do that. You could go math and then go down to this 9th one, integral, solve it that way. Or if you hit second, this trace button or calc, we can go down to option 7. That's the one I kind of like here for this one. And it says, what's your lower limit? 0 is my lower limit. What's your upper limit? We were going from 0 to 3, so I'm gonna say 3. Hit enter. And this number right here is my displacement, -3. So our answer here for displacement is -3 meters. Let's talk about what that means. It means from 0 to 3 seconds, this is moving backwards, this part is moving forward. If we add their total distance traveled up, they end up going backwards or left 3 meters by the end. That's where they ended up. But that doesn't make much sense when we say, well, how far did it travel? Because it obviously did a lot of traveling here, but it just ended up further away than when it started. So to find the total distance traveled, it's the same type of problem from 0 to 3, but we would want to do the absolute value of 4t squared minus 4t minus 7. And that was going to make this distance positive and this distance positive and kind of add it together. So if I hit math 9, I'm going from 0 to 3 for 4 t squared, but we'll be using x's, minus 4x minus 7. One issue here is I forgot put my x in there. We need to do absolute value, right? So I'm gonna need to insert that back in. So I go second, insert, and under math, go over one spot to num. There's your absolute value. All right, let's just start over here. Math 9. From 0 to 3, I'm going to go ahead and do math, go over absolute value, 4x squared minus 4x minus 7, and we're saying we want this with respect to x. You hit enter, and there we go, 19.75. So it traveled a total of 19.75 meters, but it ended up 3 meters backwards from where it started. All right, so it goes backwards sometime and then goes forward sometime. I do want to talk about another way we could have done this problem before we finish up here. The other way we could have done this problem is to break it into 2 intervals. Right, we know it crosses over there 1.91. So what we could have done is we could have gone from 0 to 1.91 of our velocity function, and then gone from 1.91 to 3 of that same function that we had up here at the top, right? Our velocity function. This comes out to be negative. this comes out to be positive. If you treat this as a positive and add it with this one, you can also get that same 19.75 number. And that's probably the official way that you should do it. We kind of do a workaround using the absolute value. But technically, you wanted to break it into 2 intervals from the time it's stopped and add those together as positive numbers. But the absolute value is going to be able to get you that same answer. If you have any questions, just shoot me an email. Hope you're doing well.